unbalanced forces, but now we're going to push it downward at an angle as opposed to pulling it upward at an angle. So we're going to take the exact same situation that we used for pulling it up at the angle, and we're going to do the question pushing down. So the block was 15 kilograms. There's an applied force. It was going this way, but now we're going to apply the force downward. Still going to be 200 newtons. And the angle that it's going to be applied at, still going to be 25 degrees. If you're pushing down at this angle, you're still going to have a force of friction that's going to be trying to oppose that motion. It's just going to get really messy if I draw it backwards over here. So another thing you can do when one side's messy, you can put the force of friction vector in front. You just indicate the direction that it's going, and it's going backwards. The coefficient is still going to be 0.15, and we're still trying to find the acceleration. So all things being the same, I'm going to put blues for my x's, and I'm going to have my pinks for my y's, and at some point in time I'm going to need to find this normal force. Might as well do it first. I'm going to find Fn. Because this is pushing down, this time my normal force gets heavier. You got to make sure that you're aware of that. So when we find our normal force, it's going to be heavier, so that's going to mean that Fn is going to have to add, or sorry, this isn't Fn, this is Fy. Fy is going to add to Fg. That's not an Fg. There. So Fn is going to be mass times gravity, that's 150 newtons, plus my Fy, which is 200 sine of 25. And when you plug that all into your calculator, you end up getting 234.5 newtons. That is much heavier than the 150 that this thing is regularly, so our apparent weight is much heavier. So for my second step here, I'm going to find my force due to friction. Well, force due to friction is mu Fn. If my Fn is much bigger, that means my force of friction is going to be much bigger. So 0.15, 234.5. So my force of friction, when you plug that in, ends up being 35.2 newtons. That's 35.2 now newtons. And it's in the opposite direction. This thing's going to move to the right. This is opposing it to the left, so I'll just put a little negative on there just in case. Third, I'm going to try to find my acceleration now. Definitely, if this thing is pushing down, there's absolutely no way that this thing can do anything. This block can only move to the right. It can't move up. We're going to always assume that the surface that it's sitting on isn't going to break and have this thing fall through. So really what we're trying to find here is AX, which means that we're going to do a sum of all of our X forces. So sum of Fx is going to be equal to all my X's. Well, you're going to have this blue, which is your Fx value. So that's going to be Fx, and I'm going to add it to my force of friction, which is in the opposite direction, and that's going to be equal to mass times AX. 200 cosine of 25, so this is 200 cos 25, subtract it from my force of friction, which I got to be 35.2. My mass is 15, acceleration x direction, solve that AX. 200 cos 25, that's still 181.3, subtract 35.2 over 15. So in the end, your AX ends up equaling 9.74 meters per second squared. Still moves to the right, but now it only moves with acceleration of 9.74 meters per second squared. There you go.